Yeah, good day, everyone. Let us dabble into a very long one like this. You can see this is a very long story, but it's solvable. This is solving bearing or elevation problem on a three-dimensional shape or three-dimensional what figure. Now, let us dabble into the drawing first, because if you don't get the drawing, you might not be able to answer the question. Okay, it's just like the normal bearing. If you don't get the drawing well, if you do not get the information and get the drawing well, then you can't get the answer. Now let us look at this together. A vertical post stands at a corner of a rectangular horizontal field measuring by a 30 meter by 40. That rectangular field is measured by 30 meter by 40. The angle of elevation of the top of the pole from the opposite corner of the field is 13 degree. Okay, we are coming back to that. Calculate the height of the pole, and we are also asked to calculate the angle of elevation from other corners, because it has other corners. You will get that from the drawing of the field. Now this is what we are going to do. Let us first draw a rectangular field, but that rectangular field must also be horizontal. You can have a rectangle like this. This is the length, this is the width or the breadth. So, but I like to use width. This is the width. Now you can also draw a rectangle like this, width, length. Okay, this is drawn vertically, this is drawn horizontally. So that is what they are mean. Now you have to draw your rectangle in this form. Okay, so another thing you must bear in mind is that if you want to attempt to answer a three-dimensional shape like this, applying elevation or bearing, you have to know how to draw that in very well. At times you need to bend the drawing. Instead of you to draw your rectangle like this, so it will be better you bend it, so that you bend it a little bit, so that the shape of what you want to, the shape of angles you want to get can comes out. Then another thing is that, because in this drawing you will be dealing with a lot of right angle triangle. Okay, right angle triangle. So now it is better to bend this, so that the shape of what you want to bring out will comes out. You will see what I mean very soon. Let us just pay attention. It's a very simple question, but it is a little bit technical. Now let us draw that rectangular horizontal. Let us draw the length. Oh, okay, let me shift it down, because we need space, because I don't want it to get close to that story. Let us draw. Okay, let us bend the width a little bit, bend the width here a little bit, and let us join them. Okay, let's manage this way. Now that is a rectangular horizontal field. Now it is measured in what? This is the width, 30 meter. That's the length, 40 meter. Okay, now the angle of elevation of the top of the pole from the opposite side of the corner is 13. Two things are involved here. The angle of elevation of the top of the pole, that means there is a pole in one corner, and there is one the angle that face that corner where where we have that pole is 13 degree. The angle of elevation, let us assume we have the pole. Let me put the pole here. No, I want a straight something. Oh no, so let me put the pole. Let's just assume this is the pole. Okay, let us assume that's the pole at one corner, just as it is said here. The angle of elevation of the top of the pole from the opposite corner. if this is, if the pole take a corner, then this is the opposite corner. So we have to trace this down. Let me get it right. I'm coming. Don't mind my drawing. So gently. Now that's the angle of what? That's the line that can produce, that's the line that can produce. I want to get a perfect drawing, please. Bear with me. Okay, let me leave that. Now we have this. When you look at it like this now, this is where they are talking about 13 degree. But before then, before you put that 13 degree, in this kind of drawing, this line, like if you have a line like this, there is always what we call projection. That will be a projection of this particular line. A projection of that particular line, because the reason is this line we have like something like a reflector. If there is sun up, it's once the sun touches this, it will reflect the line on that ground, on that plane rectangular field. So we are going to have, I want to draw here very well. So please don't mind my drawing. Don't mind my drawing. I was just trying to be a little bit I didn't mean I can use ruler. It would have been, I didn't mean I can use ruler. Yeah. Now let us manage. So this particular line actually is, it's a projection to this particular line. Let us assume I name this A, B, C, D. So let me, the top of that pole to be E. So line CE, that is the slope of that angle 13 they are talking about here. That will give, that is elevation angle. That they are saying the height of the angle of the elevation of the top of the pole, this particular pole from the opposite side. This is the opposite side of the pole, is 13. Okay, then the line I drew here is the projection of that elevation. So this line is actually the correct length that can give us the correct length, almost the correct length of that this particular one. So now we have 13. So we are asked to do what? We are asked to calculate the height of the pole. We are asked to calculate, let me call it X, this EB. We are asked to calculate the height of that pole. Okay. We are also asked to calculate the angles of elevation from other corner. Where we have corner again, we have corner here, we have corner here. Okay. We have to calculate. So we have to, let me use another pen. We will find the angle of elevation from here too. We will find here. Let me put A here. We will find here. Oh no. Oh no. We will find here. What's going on? Am I too fast? We are going to find here. Okay. We are going to find here. Let's call it B. Okay. Okay. Now, those are the things they asked us to find. But now, for us to be able to get the first thing, which is the height, we need, when you look at this, you have a lot of right angle triangles here. This is the first right angle triangle you have. We have triangle ECB. You have a right angle triangle ECB. Look at it. EC, CB, BE. That's a right angle triangle. So it means from here you can have something like this. Okay. Now from this another triangle you still have is this EB, EA, AB. That also have another right angle triangle. Okay. Now another right angle triangle you have here is this ED, EB, BD. Let me say it again. ED, DB, BE. So this piece also have what? Its own right angle triangle. I hope I'm communicating. So this is very simple. Just ensure you draw it so that it can bring out the right angle triangle that will help you in solving your problem. Now, what it asks us to find first is height, which is the height of that pole. What we need now that we know we have this place as 40. Let me use the black one. We have this place as what? 40. This length AB is the same thing as CD, 40. Okay. We also have this as, okay, what we just doing is we have 13 degree here. Once in this triangle ECB, which is ECB. If we can get this CB, if we can get CB, for example, or get CE, we will be able to get the height. Once you get one of the side of a right angle triangle and you have an existing angle, you can get the other side, any of the side. Once you have one of the side, you know you have 3 sides in a right angle triangle. Once you have an existing angle given and you have one side given, then you can get the other side. That's what I mean. So I have an existing angle here now, but we have to find height. So if I can get either CB or CE, I'm good to go. So what I will just do is that I will find, it is easier for me to get CB. When you look at this right angle triangle here, this CBD, this is another right angle triangle. But in that right angle triangle, what I have, let me shape it out. It's like this. Okay, this is C, this is B, this CB, then this is D. This is the right angle. So it means this is 40, this is 30 from this now. So this line CB is this. So if I can get that CB, I'll be able to get the height. So what I just need to do is to use Pythagoras theorem. So let's go. What we are going to do is, let me clean this because I'm going to use that side. I'm going to use that side. So I need to get CB. Side CB square all equals to CD, which is 40. I want to manage my square plus, since where I'm looking for, which CB, sorry, is hypotenuse, so I'm adding. So plus DB, which is 30. Okay? No, square, sorry. So CB square, this will be square 1600 plus 900. So if you add them together, our CB square will be, that's 25. Am I right? Yeah, 25. So you have to find the square root of, if this one is moved, it's going to be square root of 25. So you have CB, the square root of this one, 2500, I think is 50. Okay, so this length now, CB, is now to what? 50 meter. So we can now then use, okay, if this place is 50 meter, if this place is 50 meter, we can now say we have 13 degree which has opposite of height, which is x, and adjacent of what? 50 meter. So anything that have opposite adjacent is tan. That is tan from our SOHCAHTOA. SOHCAHTOA is tan that have opposite adjacent. So we are just going to apply tan 13 degree equals to what? What is opposite? X over adjacent, which is 50. So then our x now will be tan, no, let me say 50 times tan what? 13. No, let me find very quickly to save our time and our data. Let me find tan 13. Tan 13 is our s is 50 times 0.230 or 309. I approximate it 0.2309. Now let us find x. Let's say that times 50 is give us 11.5 approximately. So 11.5 meter. So the height of that pole from that question is 11.5 meter. So we have just solved that. So they ask us to find the angle. What's the question? The angles of elevation from other corners. I'll find just one of the corner, then you are going to do the rest, and you can just comment the answer, or you send the comment. Yeah, the answer is in the comment section, please. The answer is in the comment section. Pardon my English. Now, let me take one. Okay, let me take this. I have 40 meter here. From this right angle triangle, I have 40 meter here. So I was asked to find this place. Let me put it out here. Okay, I was asked to find that place. I have 40 meter as the adjacent, and I know what? I know, and I have the height, because all angle is using this height. So I have that height as opposite. So what I will just do is I will say tan theta, since I did not know it, or tan b, as I said earlier, opposite is 11.5 over, which is adjacent, 40. So tan theta, that's 11.5 divided by 40. What does that give me? So it's giving me 0.2875. No, so for me to get theta now, it means I have to find opposite of that tan. That is inverse of that tan. That's tan theta. What this means is just theta alone. Okay, what it means is that I'm finding the theta, the angle alone, once I've put the inverse on that tan. So let me find this out from here. So that is giving me 16 degree, because I'm looking for the angle. So this is the angle. Once you find anti-tan, is going to give you, and tan of this will give you the actual angle in degree. And that's it. Bye bye for now. Please comment, make suggestion on how we can improve. Bye bye for now.